Hello. In this video I want to examine what I believe is one of the faulty chains of reasoning used by flat earth apologists to try to convince you that the earth is flat. Not so long ago the apologists put forward the so-called Black Swan evidence for a flat earth. The claim was that some of the photos of these platforms were primary evidence for a flat earth. This is the first error. Why some photos? What about the other photos? The second error is misapplying accepted science to these photos to establish that a certain explanation is not supported by the cherry-picked photos. You can find many YouTube videos explaining this particular error. I've put a link to blueprints in the description. In this video, I want to explore the other faulty thinking processes that lead to this claim of evidence being made and demonstrate how they ought to be generating evidence for the flat earth. Let's look more closely at the Black Swan claim. Taking a side-on view of the scene, we have an observer looking at a distant object. The claim is that this object can only be seen because of the water between the observer and the object is flat. However, this claim is based on an inference, not any direct measurement, and this inference is faulty. From that faulty inference, they go on to assert, without evidence, that the nature of the water beyond the distant object is also flat, despite the fact that the Black Swan photos give no such information on that matter. So we have an assertion of flatness derived from a faulty inference applied to erroneous science applied to the Black Swan photos. This flat body of water is then used to conclude that the Earth is flat. Before we examine the faulty inference, how might we go about making a direct determination of the flatness between observers on opposite sides of a body of water? Ideally, we'd like to make some measurements directly between the two observers. However, flat earth apologists claim that this isn't possible over large distances for a variety of spurious reasons. So let me propose something a little more indirect. Make observations of an object that can be seen by both observers even if they can't see each other. Such an object is the sun. If we can make some measurements of the position of the sun from each location, maybe we can generate the evidence to directly show that the body of water is flat and that therefore the Earth is flat. In a previous video, I explored whether the Atlantic Ocean was flat by taking measurements from places along a north-south axis. In this video, we'll make measurements of the sun's position from places in an east-west relationship. As a reminder, the measurements of the sun's positions are the azimuth angle, the direction we have to face to see the sun, and the elevation, how far we need to tilt our head back to look directly at the sun. What we are going to do is use these measurements in an analysis that assumes that the Atlantic Ocean is flat. The squared paper represents the flat ocean, and the sun will be some distance above the paper. If our assumption is correct, we should be able to exactly position the sun relative to the observers taking the measurements. Since looking at the sun without proper protection for the eyes is dangerous, we'll use data from SunCalc website to get our measurements. In this experiment, we are taking measurements from Porto in Portugal and Montauk in New York State of the USA. As you can see from the geodata, these two places are on either side of the Atlantic on the same east-west line. The squared paper represents the Atlantic Ocean. The vertical lines are assigned the north-south orientation, and therefore the horizontal lines are running east-west. We can therefore draw a line along one of the horizontals to represent the distance between Porto and Montauk, and can use the azimuth data in a triangulation process to find the point S as shown here. The point S is the place where we will put the stand holding the sun. What we need to determine now is how high up the stand we need to put the sun to create an accurate representation of the relationship between Porto, Montauk and the sun. To do that, we use the elevation data. On another piece of squared paper, we mark the point S. We draw a pencil line vertically, which is where the sun will be, and we draw a horizontal line and mark 2 points on it, being the distances from S to Porto and Montauk respectively. We get these distances directly off the triangulation we made to find point S. Now we can use the elevation data to find the height of the Sun above the point S. Here we encounter a problem. We've calculated two different heights for the Sun depending on which elevation measurement we use. If we incorporate this into our visualization, we get this. The lower of the suns is the one being observed in Montauk, and the upper one is the one observed in Porto. This violates the assumptions that the ocean is flat and that there is only one sun. If you insist that there is only one sun, which one do you choose? If the real sun is the one seen from Porto, then Montauk must be above the flat ocean. If the real sun is the one seen from Montauk, then Porto must be below the flat ocean. A flat ocean is not consistent with our measurements. If you want to retain the assumption that the ocean is flat, then you need to account for there appearing to be multiple suns. That brings us back to the faulty inference, which is the backbone of many claims of evidence for a flat Earth. Apologists start by stating that the Earth is either flat or a sphere. Then follows the claim that they have shown it is not a sphere, and therefore it must be flat. This is the faulty inference. The issue is that the flat or sphere statement is a false dichotomy. If you clear your mind of any preconceptions about the shape of the Earth, then as well as flat or spherical, you have to admit that it might also be any of the other regular polyhedra, such as a tetrahedron or a cube. Not only that, it can of course be any other conceivable shape. In that context, claiming to have eliminated the sphere does not allow you to infer that the Earth is flat. But let's assume that you have found a way to eliminate these other classes of possible Earth shapes. What then? The Black Swan evidence is used to assert that the Earth cannot be a sphere and therefore, by inference, the Earth must be flat. This is not valid reasoning. The error is that the apologists think the sphere of the right-hand side of the oar is a single object. It is not. This is still a false dichotomy. In this statement, sphere denotes not one sphere, but all spheres, which is an infinite set. The Black Swan evidence is used to falsify just a single instance of that set, which we'll call the Black Swan sphere. Now, it's not difficult to argue that spheres of radius less than that of the Black Swan sphere are also eliminated from the set under their faulty analysis. But, by the same token, larger spheres must remain as possibilities for the shape of the Earth. Even if you manage to reduce the dichotomy to flat or sphere, you must eliminate all spheres through evidence before you can infer that the Earth is flat. Let's summarise the faulty thought processes used by flat Earth apologists in presenting the Black Swan photos as evidence for a flat Earth. Firstly, there is cherry picking by selecting only photos that appear to show what they claim. Next, they misapply or deny the use of relevant science in the analysis of the photos. They use the faulty science to resolve a false dichotomy on the shape of the Earth to claim that the Black Swan photos show a flat extent of water from the observer to the furthest object. They then assert, without evidence, that this locally flat water extends beyond what is shown to the other side of the body of water. What you see here is a chain of bad thinking to try and bring you to the conclusion that the Earth is flat. What they never do is to try to generate direct evidence that the Earth is flat.